If you've ever used something like ChatGPT or any of these advanced AIs, you know the feeling. It's that little moment of, well, magic, where it seems to just get your question, connect all the dots, and then hand you this perfectly reasoned answer. It really feels like you're talking to something that thinks.
But here's the big question. Is that what's really going on? Is the AI actually reasoning, from the ground up? Or is it pulling off an incredibly sophisticated magic trick? Okay, let's dive into this, because figuring out the difference is absolutely key to using these amazing tools the right way.
So here's our roadmap for this explainer. We're going to start with a simple test for what reasoning actually looks like. Then, we'll get into why AI is more about retrieval. We'll expose the trick with some really clever experiments, talk about how to get the best of both worlds, and then wrap it all up with why this matters so much. So, first things first. How can you even tell if someone or something is actually thinking and not just spitting back a memorized answer? It's a classic problem, right?
Let's use a fun one. A famous old interview question from Microsoft. Why are manhole covers round? Now imagine you're the very first person who ever had to answer this. You'd have to figure it out completely from scratch.
That first person had to use actual geometry, right? They had to realize that a round cover, unlike a square one, can't be turned and dropped through its own hole. That's real reasoning. But today, most of us just retrieve the answer we've seen online. The final answer is identical, but the process for getting there is completely different. And that difference between reasoning and retrieval is at the very heart of this whole conversation.
And that brings us to the core of what large language models, or LLMs, are really doing. Are they the genius reasoner, or are they just the world's best interview prepper who's seen every question before?
Well, as AI professor Suparao Kumpampanti puts it so well, they're basically Ngram models on steroids. He calls them approximate retrieval systems. And that's such a powerful way to think about it. They aren't thinking machines. They're search and retrieval engines, just on a scale we've never seen before.
So what on earth is an Ngram model? It's a really simple idea, actually. It's all about predicting the next word based on the words that came before it. If I say, the cat sat on the, your brain just instantly fills in Matt. LLMs do that exact same thing, just on a massive, massive scale, using a huge amount of context to guess the most statistically probable next word.
So here is the crucial point, the absolute key to the whole illusion. The feeling of reasoning comes from the fact that these models have been trained on pretty much all the text on the internet. They've become perfect mimics of our grammar, of our style. And because we humans find things like grammar and style to be difficult, when we see a machine that's perfected it, we just assume it must have also mastered the logic and the content underneath. But it hasn't.
Okay, so if it's a trick, how do we prove it? Well, scientists have come up with some really, really clever tests to basically peek behind the curtain and see what's actually going on. The method is called a diagonalization argument. Now, that sounds super complex, I know, but the idea is actually very simple. You design a problem that forces the AI to use a general rule, not just an example it's memorized. If it really understands the rule, it'll have no problem. But if it's just retrieving what it's seen before, it's gonna fail. Okay, let's look at the first experiment, the blocks world. Researchers asked GPT-4 to solve a simple puzzle, just arrange some blocks into a specific pattern. First, they used normal words like stack and unstack, which GPT-4 has seen millions of times online. But then, they did something brilliant. They replaced stack with a total nonsense word, feist, and unstack with slap. The logic, the actual puzzle, stayed exactly the same. And the result here is just fascinating. With the normal words, GPT-4 got it right about 30% of the time. Not great, but it could sometimes figure it out based on patterns that it had seen. But with the nonsense words, its accuracy absolutely plummeted to almost zero. This shows so clearly that GPT-4 hadn't learned the logic of stacking blocks. It had only learned to connect the words stack and unstack with certain text patterns. All right, let's move to another test that builds on this. The Caesar cipher is a simple code where you just shift every letter a few places down the alphabet. A system that truly gets the rule should be able to decode a message no matter what that shift is, whether it's by 2 letters,
4 letters, or 13 letters. But look at what happened. GPT-4 was nearly perfect when decoding a cipher with a shift of 13, but for almost any other shift, its performance was basically 0. So why? Because a shift of 13 is known as ROT13, and it's a famous, very common command in old computer systems. The internet is flooded with examples of ROT13 text. So the AI didn't learn the rule, it just memorized the one example it saw over and over again in its training data.
So if LLMs are these brilliant retrievers but pretty poor reasoners, does that make them useless for tasks that need real logic? No, not at all. It just means we need to use them in a much smarter way. The key is to see them as a partner. LLMs are fantastic at creative brainstorming, coming up with analogies, and capturing a certain style. Formal systems, like a calculator, are the exact opposite. They have zero creativity, but they are perfect at verification and following rules. They're two sides of a really powerful coin. And this leads to a really powerful framework called LLM Modulo. It's a simple 3-step loop. First, you let the LLM do what it's great at, generate. Just come up with tons of creative potential solutions. Then, step 2, you use an external verifier, a separate program that knows the rules, to verify if any of those ideas are actually correct. Finally, you feed that simple feedback, even just a yes or no, back to the LLM to refine its next round of guesses. This hybrid approach is so powerful because you're getting the best of both worlds. You get the limitless, creative pattern matching of the LLM, but you also get the guaranteed correctness that only a strict logical system can give you. You're not just hoping the LLM gets it right, you're actually proving it.
So, let's tie this all together. Why is it so important to really get this difference between retrieval and reasoning? Well, because it should fundamentally change how we interact with these incredible tools.
Okay, so let's pull out the key takeaways. Remember, these powerful tools are retrieval engines. First and foremost, not reasoners. Their magic comes from mastering the style of our language, not the content. And that means, this is the big one, for any task where being correct is critical, you have to bring in a verifier. Knowing their limits doesn't make the tool weaker. It makes us smarter partners.
There's a great story about Albert Einstein being told that 100 scientists had published a book against his theory of relativity. His response just perfectly captures this whole idea. He said, if they're right, 1 is enough. If they're wrong, 10,000 doesn't make a difference. It's such a great reminder that when it comes to truth and correctness, it doesn't matter how popular or plausible sounding an answer is. Only verification actually matters. So we're left with this question. We've seen behind the curtain now. We understand how the illusion of reason is created. But knowing how the trick works doesn't mean the magic is gone. It actually means we can become the magician's assistant. So how can we as users become smarter partners with these incredibly powerful, but ultimately non-reasoning tools?